Okay, so bilinear forms used to be confusing to me. Let's see, how to make this bigger. Okay, bilinear forms are literally just functions that take in two vectors and must be linear. Okay, that is literally it. The most common, most popular, and most famous example is that even high schoolers know is the dot product. That's it. Okay, so a bilinear form B eats up V and W. These are two vectors, and it just gives you some output. Okay. Yeah, very often a number. And yeah, that is it. The linear part means that, okay, suppose I have vectors A, B, C, then B of A plus B comma C is just equal to B A C plus B B C. Okay. Yeah, and same thing goes for this one, which I will type out. B of A is equal to C is equal to B A B plus B A C. Yeah, that is pretty much it. And if it is the case that so now let's look at if it is the case that B A B is equal to B A, then we call this a symmetric bilinear form. If B A B is equal to B negative B A, then this is called skew-symmetric or antisymmetric, which is way more of a famous and used label. Yeah. Okay. And so next, I will be using bilinear forms to define the symplectic group. Yeah. So the linear forms just take two vectors and return. Bilinear forms are just functions that take in two vectors and produce a number. Input two vectors, output number. That's it. Must be linear. Must be the let's see. The inputs must respect linearity. Let's see. Yeah, must respect linearity, which is to say this. Yep, that is it. And next we'll be using it to define the symplectic group, which is used in physics and the Langlands program, symplectic structure, and so forth.